Okay, I nearly forgot to start the recording. Okay, let's me share sound. Okay, which one should I? Okay, I also would like to let's discuss about our paper tools challenge. If you still remember, the one that you did during the semester break, right? During the Hari Raya break. Okay. Let me see. Okay. I am still marking the whole. Uh, I mean the paper tools uh, report that you have submitted. Okay. Before we go there, let's see the slides first. Okay. No, this one. So today, quite terbulat dalam Brian Silva. Okay. 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 All right. Let me take the picture. Okay. All right. So do you still remember this paper toast challenge? I'm not sure if the master students that joined the class, they still remember it because they don't have to do this. But so all of you have submitted, all of you have mentioned about the strategy. I'm kind of like the concept of when you are highlighting on basketball throwing concept. So uh, you try to make use of that knowledge. I can see that in Chai Sean's report about it. And then I also kind of like when you try to highlight on the features such as force and angle. Okay, there are few people also reporting on how actually they try to consider all the factors in order to ensure the paper tools is successful. Okay, so here what I would like to highlight, or probably what we want to discuss, is about things that you do correctly, or there are mistakes, or something that you can improve for the future assignment. Okay, all right. So as you can see here, this is one of the report. I'm not sure the owner can recognize himself or not from the picture. Okay, what I realized from this report, suddenly the change of the strategy is, I mean, there is a change of strategy. As you can see here, this down toes, and but suddenly in the third stage or the third distance, when it was 3 meter, he changed it to the upper toes. So there is a inconsistency of strategy. Probably in the future you have to include that kind of consideration of change or changes in your discussion. Yeah. Okay. Right. So what I can observe, more or less, everyone is reporting this kind of um, data recording, or result recording, whereby you record your attempt in 2 meters, 2.5 meters, and 3 meters, and you put them into one table, which is very good. And I kind of like it where you have the legend rather than you put it success or fail, because it's going to be very long, and it's hard for us to observe or count it. Yeah. What I would like to add here is it's going to be good to have this table and include total performance at the last column. Okay, so some of you calculated maybe 7 out of 10. You put it in other table, or in just paragraph. For engineers, normally we directly look at our data or our results or our plot, so that if possible, we would like to put all the information inside that one plot or one figure, one table. So if it's good if you have the total success, okay, and also the success rate. I think Lukman calculated the success rate. Okay, many of you just mentioned about how many successful throw out of the total one. Okay, so it actually you have many points to discuss. Probably you don't know how to elaborate it. So some of you just report on these results, but you are not able to relate it to the machine learning concept. Okay, all right. So that it's something that you have to improve on. Okay, right. So before I show you on my remarks of the individual reports, I think I have done half of the class already. I can see the trend lah. Okay. Before we proceed and look at um, the individual report, may I know what actually that you understand from this paper toast exercise? Anyone?
From my understanding, lah, Doctor,
Mm-hmm.
this is basically trying to trying to show the how machine learning is work lah.
Okay.
So at first stage, we don't really know what we're doing, right? We don't really have
Mm-hmm.
any idea, strategy,
Mm-hmm.
or whatsoever. So we just do it first,
Mm-hmm.
and then after several time, we find a strategy that we can
Mm-hmm.
get it work. So like machine learning, at
Mm-hmm.
first the machine does not really know what is the correct way, but
Mm-hmm.
then after a few results, it start to when it's then a lot of correct result, then the machine learning start to become more accurate.
Okay.
So that's
Okay.
what I understand lah.
All right. That's what Hadi's understanding. Yeah, I think that is reflected from your report about that, Hadi. Okay. Other than that, if we would like to put them into this for components, yeah. I think nobody is mentioning about the input. Probably features. I can see that some of you are highlighting on features like angle and force. I cannot recall who. Maybe I don't remember. Beijing maybe, because I just read a few reports. But later in my remarks later I can recall that. So very rare. I mean, not many of you are emphasizing on the input. Maybe data collection. Some of you, I think, Hazman put on data collection. Um, okay, so preparing of the data, preparing to collect data. Okay, preparation for collect data. So supposedly when you on ML, you have to put on this component. So highlighting on the input, or some of you may put it as features. What are the strategy? Okay, so strategy can be uh, on the your paper tools mechanism, okay, in order to ensure the successful rate. And then you may highlight on the attempt, okay, or where you can have it into training data and testing data. Some of you put it in such a way. Okay. Um, the best part, most of you are highlighting on training and testing. Okay. Jap, Chai. What do you discuss about training and testing, Chai, from your paper toss challenge?
Sorry, doctor. Like what
What
I've
do
discussed.
what you discuss based on training and testing from your report?
Uh, if I'm not mistaken, wait, doctor. I even dah
Uh-huh.
lupa already. Uh, Let me open back my.
The report you forgot already.
Hmm.
Everyone boleh lah open up your report, just in case you forget what actually that you report based on the challenge, because I think some of you submitted very short report, some of you can discuss very well. Okay, So why I am sharing here today is because I want you to look at the good example so that later you can improve.
Okay, doctor. So I have looked back my report.
Uh-huh.
So at first I discussed about the strategy lah, like the
Uh-huh.
tossing strategy.
Mm-hmm.
So yeah, I say I use 2 fingers to hold the paper ball,
Mm-hmm.
and
Mm-hmm.
yeah, so that the the propel angle of the paper ball will be consistent lah, which means
Okay.
that yeah, it will be consistent lah, which means the ball will go straight lah, it wouldn't go to it will be more consistent, I would say. Yeah. Then
Okay.
after that, then I say the machine learning concept. This is what I feel like in my opinion. I say that the
Mm-mm.
machine learning concept that is related with this challenge is the supervised machine learning concept.
Yes, it is correct. Supervise.
Yeah.
It's a correct.
Yeah.
It is a correct one. Okay.
Uh,
Do you mention when you comparing the between distance 2 meters, 2.5 meters, and 3 meters? If I'm mistaken, you mentioned something.
yeah, I got mentioned the success rate lah. Like
Yeah.
for 2
Okay.
meters, it's only 50%.
Because Chai nearly perfect tau. For everyone, FYI, Chai is nearly perfect. He scored all of the distances. I think only one or two failures. So I was like, okay. And even I think the 2.5 and 3 meters are performed better than 2 meters, right, Chai?
Yeah, I think
Uh,
so. Yeah.
okay. Okay.
Because
Uh-huh.
for 2.5 meters and 3 meters, I only did 5 tosses. So yeah.
But all are success.
I think 2.5, 4/5, then wait, let me see back the
Yeah.
result. Yeah,
About
2.5 one is 5/5, then 3 meters one is 4/5.
yeah, quite good. Very very good. Most of the your friends, they reported okay. The 10 truths, maybe 6 or 7 success. For the 2.5 and 3, they only get at I think average 3/5. Yet you get 4/5 or 5/5. So it's very good. Pejin got 0/5 for the 3 meters, right, Pejin? And even the 2.5 meters also. It's
Yes, I
total.
actually tried many times already.
Yeah, that's why I highlighted in Chai's report. I asked, yeah, I put a remark saying that what is actually contributing to your um success, because nearly perfect. But maybe Chai's strategy of 2 fingers maybe is the main factor, probably.
Yeah, maybe.
Have you tried with the whole hand?
Mm, yeah, initially I start with 3 fingers lah. Then I
Mhm.
found like wow, the angle is just lari already. So
Okay,
yeah,
okay.
because it's like how to say the because if 3 fingers mean the
Because
force
you're more movement.
the
Okay,
more force is exerted on the ball, so it will become very inconsistent lah. The
okay,
angle,
okay.
yeah, that's what
Good
I
one.
found. Yeah.
Yeah. I think so too. Because most of your friends, they are using full hand. So we're using full hand. Beijing using full hand kan? Beijing, all the fingers, right?
Yes, I never considered about 2 fingers, 3 fingers.
Ini Chai secret recipe. Chai, are you basketballer?
No, I'm not.
Not
I'm not.
kan?
Yeah,
Oh,
bukan.
okay. Maybe Sean dengan Brian kot basketballer. Okay. The one that Chai highlighted on supervised ML, that's actually very correct. Okay. And then I think many of you mentioned about the Training is 2 meters. 2 meters is train. Okay. And the other distance is testing. Okay. So it's also true. 2.5, 2.5 meters and 3 meters are testing. Okay, that's true. Okay, and some of you also highlighted on you train many times. There are 10 attempts in the training session. That's why you can get a good score. But for 2.5 and 3 meters, you only have 5 attempts, okay, to in order for you to get successful toss. That's going to be very hard. And you also mentioned about you train on 2 meters, but suddenly you test on different distances, which much harder. So you relate that to unseen data or new data. So that's very correct. Okay. So the understanding is good. Okay. I think I don't remember who, but also mentioned about the learning process. I think Lukman. Lukman, did you mention something about learning process, Lukman?
I can't remember. Just wait.
Tengah buka report eh. So few discussing on learning process. But the most common is about the training and testing, which I'm happy that you can relate that to supervised machine learning. Learning process, I don't remember whom, but probably Lukman. Let's wait for Lukman to confirm. But I came across a feedback. Okay, the word feedback. Who, if you can recall anyone, if not, I have to refer to my remarks later on.
Doctor, can you repeat your question again?
Okay. Did you mention about learning process in your discussion?
Wait, Doctor.
Okay. Or maybe Lukman is on the more training will provide better accuracy.
I don't think so, Doctor.
No.
But I did say I tried a few strategy lah, Doctor.
Okay, all right. The conclusion apa? Your conclusion, Lukman?
I was able to relate challenge with machine learning concept, and then to explain lesson learned from the challenge, successfully determine the strategy used to increase success rate.
Okay, all right. Maybe yang I think Lukman mentioning about the trading RC. Okay, tak apa. Let's see the remarks then. Okay, maybe some of you are not done yet, yeah. So don't be sad. Can you see my Excel sheet now?
Yes.
Yes. Okay. So there are a few of you that I already marked. Yeah. So if you let me zoom skip. Okay. So I'm taking a long kind of a longer time to assess everybody because I am like giving a summary of what is your report about. Yeah. So the total marks for this paper 2 is 20%. if you are looking at Hazman, it's okay if I'm show you your marks and also your name. This is only 20% out of many more percent of assignments, so don't worry about it. So he mentioned about the ball tossing knowledge, and then he mentioned about on data collection, output, and learning experience. He is based on the strategies or stages of machine learning. However, it's lacking on training on and testing stages. Your results match with ML concept, meaning that when I mentioned that the results are matched with ML concept because your training accuracy, training success rate are the highest. Okay, when your training accuracy or success are the highest, meaning that you are training well, because you have been trained well. But uh, so that when you go for testing, which is 2.5 meters and 3 meters, if you failed, it's okay because your training was on the distance of 2 meters. So it is logic, you get good score in training, but later it will be degraded. So the higher your distance is increased, so your score will be reduced. So that is what I meant by the results are matched with ML concept. Okay. So for Amir, okay, Amir, it highlights on the more distance is increased, the harder, bukan the harder to get the successful toss. So the discussion is there. Hazman results is there, but no discussion about it. Okay. You can stop me if you want to ask question because this is about your marks. Yeah. And then, so for Amir, the discussions and the results are there. That's why he able to discuss it and try to relate it. But the report didn't relate to training and testing. So the perfect one, if you can relate the 2 meters is training, 2.5 and 3 meters are testing, and then you can relate about the increment of the distance and also the decrement of your score. Okay, for Chai, okay, it's a very structured report. Don't worry about the rest, it's still empty because I'm not done with it yet. So very structured report. You have the problem statement, objectives, and method. Okay, because most of you are just go straight to the challenge, go straight to the strategy, and then present your result. A learning process and termination are explained for the toss attempt. So this is something that not many of you able to highlight. So so what is Chai trying to discuss here is because you have only 10 attempts, so you have to terminate the learning process. However, 10 times is good enough because that's why you can get good score. Okay. Um, it's just that for Chai, because it's nearly perfect. So supposedly Chai can add on why the performance is very good for all these distances. Maybe if Chai can report on if he is using 3 fingers versus the 2 fingers, maybe we can see the success or the impact of using 2 fingers. Yeah. But for now, I'm not sure why Chai score is very good. Okay, next is Aina Afika. So the size of bin is stated because some of you, I can see that you use a very small bin, some very big bin. Okay, the opening is very big. So supposedly, of course, you can get a very good paper toast. And then the strategy is mentioned, supported by flowchart. However, the discussion is not related to the performance of different distances. And yet, the results are there. The score is there. It's very, I mean, when you're comparing 2.5 and 3 meters, you can see the decrement of performance. Yeah? For Hadi, the strategy is not explained clearly and discussions are very brief. Okay. Hadi didn't mention. I think Hadi mentioned about the top top throw and up to down throw and down to top throw. But then it is not stated which one is actually the one that Hadi is using. If you can have that comparison, Hadi, in order for you to decide which strategy that you use, probably it's going to be much better for your report. Comparison table is good. As you can see, the one that I select and put in the slide is coming from Hadi. Okay, the size of opening is quite big for Hadi, but I think Hadi is also the results of the toss is still matched with the ML concept, meaning that the 2 meters are good, and then the performance is decreasing. Luqman report is also very structured. Success rate is calculated, something that no others are reporting on that. You just give me the score of 7 out of 10. Okay, so success rate meaning that is the percentage. So it's gonna be easier for us to look rather than 7 out of 10 versus 3 out of 5. So it's gonna be like hard to compare. But if you normalize it to percentage, so you can compare 70%, but then the testing is 60%. So it's very good. Okay, Luqman also mentioned about the supervised learning. Okay, and mentioned about the training of 10 toss and 5 toss of testing. So that's why the score are lower. Then Aiman Hakim. Okay, the early part of the report is very good because the flow chart of strategy is provided. The performance also match with the concept of supervised learning. Later we will look at Aiman Hakim video. Okay, so that he is consistently. Let's watch now lah. Okay, if you look at. So if you look at how he performed the toss, it's very consistent. Okay, because yeah, Alif.
Ini bukan Aiman.
Ini siapa?
Ini Hazim.
Hazim. Okay, sorry, salah orang pula. Nasib baik tuan punya diri tak cakap apa-apa. Okay, this is Hazim. Tadi kita we are looking at Aiman's report, but we are looking at Hazim now. Which I think it's a very controlled course. That's why I picked this video. Okay, so if you look at that, it's very consistent compared to other video or the way that you perform your paper toss. It is it is very, sometimes you move or the way you throw is a little bit different. So it's a very controlled movement. So Aiman tadi, okay, Aiman, I didn't watch the video, but the discussions are very brief. So Aiman, I think the content is there, the results match. Probably you should highlight on the how actually the machine learning can be observed from the challenge. Okay, next Alif.
Right.
Okay, thanks. So, sorry salah orang tadi Aiman. Okay.
Saya suka tengok Azim punya.
Saya suka tengok Azim punya kan. Azim punya macam ceri-ceri sikit video dia. So Alif mention on basketball steps. Okay, flowchart is provided. He able to relate with learning and achieving the desired results. Attempts to learn is also explained. Alif is the one that mentioning about the feedback concept. So the way Alif mentioned is that when you have throw one toss, let's say it is a success, then you remember it. You try to repeat it again. But when you make errors, you also give the feedback to say that, okay, probably reduce the force or make sure your body, or maybe you focus more on the target area. Okay, so I kind of like it when you relate that to the feedback. Okay. All right. So next is Bernard. Okay, Bernard. explain the whole challenge very precisely as ML. Very good job, Bernard. It just that it's gonna be better if you can mention that about this three style, because you didn't detail it out in the report. So I'm not sure what is the differences between style A, style B, and style C. So probably in the next report to anyone, if like say you have few strategies and you already mentioned or you give name to it, better if you can put the detail of that approach or that strategy in the report, so that for the examiner or for me to read it, so I can relate. Okay, style A is using this, style B is using this. Okay.
Yes, doctor. Thank you
Uh-huh.
for reminding, because that was my initial plan to show
Uh-huh.
all these styles before I finalize the style that I'm using.
Uh-huh.
Unfortunately, I just forgot to include the other two styles in the.
Yeah, so it was like hanging. Okay, what is style A, B, and C are not there. But the way that you explain, okay, this is training. This is how you decide on the strategy. What is your output, the targeted output, what is your input. So, and then the feedback, the learning process, and so on. Very. It is the one that should be discussed in this challenge. Yeah. Okay. So good job.
Thank
So for Beijing, Beijing is highlighting on the features, force and angle. And then she mentioned about the paper shape. Okay, nobody is talking about paper shape. Everyone is focusing on yourself. Okay, what you should do, you should stand straight, make sure your eyes are looking at the target, blah blah blah. But Beijing is also considering the shape of the F4, how you crumple it. Okay, and then the training time and successful toss are explained. Okay, and then so Pigeon got failure for 2.5 and 3 meters. Okay, totally failed. I really like to know the discussion about that, but Pigeon didn't, you didn't explain, didn't relate to ML. Pigeon? So if you can mention, maybe you need more training, because of the training is not enough. That's why the testing on 2.5
But
and
I
3
do
meters.
mention that because there's no practice for 2.5 and 3 meter.
Okay, yeah, because there is no practice. So um that's why you get all failure.
Yes.
uh, Try relate that to training and testing. You can say that the 3 meters and 2.5 meters are totally new data. Okay, because you just mentioned without training. But I am wondering why the K-means is coming into the story. Pidgin?
Because I thought we should apply one concept of one of
Okay,
the intel inside, and then I
okay,
think that chemist is like clustering of the result. So maybe
okay,
the force and angle I apply too much, and then they will overshoot. And then if I want to have a perfect shoot, maybe I need to have a uh correct angle and force apply.
okay,
That's
all
why I
right.
put the chemist
Okay,
graph.
okay. Okay, let me share a paging report so that you can see what is paging mean by that. Yeah, let me stop sharing. Um, Beijing and Sean, they presented a bit different concept, but I would like to know why. I'm not saying that they are wrong, but I just want to know what is their thought when they are discussing that. Okay, let me share the PDF. Okay. All right, so this is what is Beijing's idea. This is Beijing's idea. Actually, it's still correct. Okay, Beijing. So you don't have to worry, because once you have this plot, then I can relate lah. What do you mean by K means? So Beijing's perspective, when what she's doing with the paper tools is the data collection, right, Beijing? So she tried to relate with the angle and force and try to cluster the paper tools into three categories. So the success, the undershoot, and overshoot. Meaning that if your angle is a little bit small and low force, maybe you will have undershoot. So if the optimum angle and optimum force, you will get the success. If too much angle or too much force, you get overshoot. So actually it's still correct. Okay. So it's totally different from the others. Probably others are just talking about ML in general, whereby you have the training and testing, etc., etc. But here, Beijing is looking at the challenge as a data collection and how she is going to analyze it, considering two features, angle and force. Okay, so it's also correct. Anybody would like to add more? Beijing, maybe you want to add more on this analysis that you have done?
No.
No, okay. Don't be scared, Pigeon. Maybe you go to, alamak, I'm totally different from the others. But it's still correct because you have this kind of, discussion. Yeah. Okay, let's see. Stop sharing. Now go to, okay. The rest is nearly the same. The Aldin also mentioning about the supervised ML. And then Aina Fakihah also mentioned about the learning. Sean has interesting discussion on concept of ranking and feature extract reduction. Okay, let me open Sean punya report. Okay. Okay, let me share my PDF. Okay, so this is a Sean strategy. Okay, so what he highlighted in this report, he has 4 strategies. So this is, he called it later as a feature. Yeah? So feature 1, aim the back rim. Feature 2, elbow bend at 90 degree and point at basket. Feature 3, toss the paper ball higher, more than 45 degrees. And feature 4, follow through the arm. Okay, so these are actually the strategies that later on come. He called it as features, which is also correct. And then, okay, in his discussion, he relate that the distances as classification, meaning that group 1 is 2 meters, group 2 is 2.5 meters, and group 3 is 3 meters. He also relate to ranking. This one I'm not very sure. Later I want probably Sean can add on how actually he get the idea of ranking. But the dimensionality reduction is something that which is correct. The way he discussed is correct because he said that he got 4 features or 4 strategies, but later he realized that strategy number 3 is not applicable to this challenge. So he can reduce that features and only focusing on the 3 features for the rest of the challenge. Okay, so yeah, it's still correct. Sean is around, right?
Yes, Doctor.
Yeah, Sean. For the ranking kan, Sean, you jangan gelak dulu. Tiba dia tengok, oh my god, what I was thinking at that time. Okay, for ranking, what is actually your impression at that time? I mean, how do you relate it to ranking?
So my thought is ranking is I will rank the difficulty. For example, 2.0 meter is the easiest one because it has the highest probability. Yeah, that is my thought.
Okay, so based on the distances lah, and also the difficulties level. Okay, this part probably I have to say is not really is not matched lah. Ranking normally we are talking about on the image on the retrieval of information. So if you have selection of answers, so maybe we only choose top 3 or top 5. So from that we know if the the correct answer or the one that we are looking for is in that rank or not. This is similar to the search results by Google, whereby you have let's say you search for a keyword, then you have a bundle of pages, right? List of pages for as the answer for your searching way. Okay, so the way they rank that page, that is the ranking. Okay, but for this one, it's not. Yeah, the difficulty level. Classification maybe yes. Okay, because meaning that the attempt you can have it as one single data set or single point. So it can be similar or it can be not similar. Okay. All right. Okay. So so any question? Those are the one that I already mark. Okay, but I can see the pattern is around that idea. Anyone has different idea when you do the challenge? Probably you would like to share. You want to share it with the class so that maybe something that everyone didn't realize. Anyone different thing, probably you don't see the relation to training and testing, but you get other idea or other perspective. Anyone? Tak ada. Okay. Tak ada. Okay, you are looking forward for the next one sabar. Next assignment, doktor, please lah. Okay. All right. Share this one. Okay, so that's the comments. My comment based on your paper tools. Okay, so at least now you can see, okay, if you would like to relate it to ML, you can have these components to relate on. Okay. All right. So next machine learning exercise is an individual task. Okay. So you can do it start by today until 16 June 5 p.m. 16 June is Wednesday. Okay. What I want you to do in this exercise is you choose a data set that you want to work on. So you have two options. It's either you use your own FYP dataset or you can use IRIS dataset. Later you can see what is IRIS dataset. So if your FYP has nothing related to nothing related to ML, then you can use the IRIS, because IRIS dataset, it has many tutorials online, and even I provide the link also for your reference. Okay, so first thing you choose the data set, then you learn the ML tools that you want to use. So I'm open. You can use MATLAB, you can use Scilab, Python, or any other tools that suits you. There are also R that can be used as a classifier to develop classifier. And then choose the ML model. So because we have many types of ML model, you can have a feed-forward one, you can have backpropagation, and then we have multi-layer perceptron with different architectures, different layers, different activation function, etc., etc. So my advice is you use the most standard one and just use the default first. Okay, you don't have to tweak or change any of the value. So once you find one ML model that has potential to be used as classifier, then you can learn about it, okay, and understand the model parameters. So meaning that I just want you to familiarize yourself with learning rate, the input, the output, and then how you divide the samples or the data into train or testing or validation. Yeah. So write the report on your exercise covering the background of your classification problem. So if you are on the FYP dataset, then you have to mention about what is your problem statement and what is the goal of classification. So if you are working on IRIS, then explain what is the IRIS classification problem and what do you want to achieve from that. And then brief information on your data set. So this may include features if you use them. So some of you, maybe you just use raw images, like Ame, and Aiman, right? Yang buat face classification, wearing mask or not wearing mask. Betul? Lukman ke Okay, so
Ya, saya.
okay. So Lukman, Amir, they use raw images. So maybe they don't have the features, but for the rest, maybe you include the features in your machine learning exercise. So you have to explain about that and how you divide the data into training and testing. So if you use any function in the tool, so you please mention about it, and how are you going to ensure that the division of these data sets are fair or random enough. Okay. Then diagram of the ML model. So let's say you are choosing the backpropagation model. So you have to explain what is your input layer and then the hidden layer and also the output layer, where your backpropagation will goes to. Okay, normally it goes to your weights after the input layer. And the configuration using the tool. So configuration normally when you have to select what kind of activation function, how many layers, blah blah blah. So so in the report you can have a very you can have a diagram, and also maybe you just mention out, okay, what are how many layers you have in the paragraph. Later, the source code can be added as appendix. Yeah? Next item is on the model performance, such as accuracy, loss, specificity, sensitivity, precision, and others. So what you have to discuss is you have to make sure the performance are good, which are exceed 80% accuracy. If you don't get it, please let me know, okay, before you prepare the report. So at least I can suggest to you what are the things that you can tweak or change in order for you to get the 80% accuracy. But for iris, don't worry, because from the literature, there are many models have been tried, and most of them, they can achieve 90% accuracy for training and testing. Yeah. So the discussion should relate on the chosen ML model. So let's say if it's very good, maybe 100%, 100% accuracy, you should mention about probably the selection of the features, the selection of the hidden layers, and then the activation function, or how the feedback from the errors are taking into account for the next iteration or the next epoch. Okay. So this is the data set that you can choose. First is on your own data set. So if you have your own problem, you have filtered or you have cleaned up your own data, then you have to mention that. So you can just proceed with your FYP data set. If you don't have anything and your FYP is totally not related, or you don't have many data set or many data for FYP, you haven't collected your data yet, so you can use the iris. It is a flower iris. There are 3 species of iris. Okay, so iris setosa, iris versicolor, and iris virginica. So you can you just Google this, that you can get the database of this features. So it will give you the Excel file with the features, numerical features. So I also provide you the tutorial, okay, step-by-step tutorial using Jupyter Notebook that you can have here in this link, or the one if you want to use MATLAB, you can follow this link. Okay, so it is very structured and very, guided tutorial. Okay. All right. So before we go to next topic, we have many topics. I think we have 3 more topics or 2 more topics to cover in AI. Any question with regard to this new exercise? 2 weeks is enough for you since we also have project. Remind me, I have to explain about project. Any question about ML classification exercise? It is individual, but you can discuss. You also can, maybe let's say Peijin and Kaka, they are working on Iris, and then maybe Peijin using one ANN model and Kaka using another model. So yeah, no problem. Any question? Dah tidur?
Tak tidur.
Tak
No.
tidur? Okay tak this assignment?
Okay kot. Okay
Okay
dah.
kot. Okay 2 weeks. Ni Hazim kata okay tau. Others tak cakap apa-apa pun.
Tak cuba lagi tak tahu.
Tak cuba lagi tak tahu. How many of you first time using the tools for ML? Raise your hand. Meh, saya tengok.
Saya.
Raise hand pakai
Saya.
time, meaning that you don't have anything related to FYP. So you may need like 1 or 2 days at least to read around. Okay, let me see. 1, 2, 3, 4, 5, 6, 7. Only 7%. Okay. 7 Okay, do you need a mentor? So that we can pair. So let's say those the first time can get guidance from the person that already familiar with machine learning or the tools.
Doctor, it's actually 13 people.
13
Not 7.
Yeah, 1, 2, 3, 5, 10. 13 this page nampak semua. 13. It's not 13, it's 14. Kita ada Jihang, Aisyah, Hadi, Sean, Hazman, Azina, Aina Afika, Aina Fakiha, Chai, Hazim, Brian, Peijin. Brian tangan dia cerah sikit. Peijin, Husna dengan Nurazira. Okay, first time. Okay. Do we agree with the mentor? Hazman dah book. Amir dah.
Nak ambil juga.
Siapa tu? Hazim nak ambil juga? Oh, glamour Amir.
Saya pun nak ambil.
Siapa yang nak ambil juga?
Saya nak ambil.
Ada gaji.
Amboi, Amir ada gaji. Nak A FYP?
Nak.
Hadi nak juga, Azina nak juga. Okay. Kakak mana kakak? Kakak tak ada
Yes, doctor.
You ada kakak here. Kakak familiar kan?
I think should be same, right? Deep learning and machine learning.
Yes.
Ah.
So deep learning is just that you input raw images lah. So kalau macam Peijin, Sean, semua they can use Iris. So it's already in numerical values. So much, but the model similar. Kakak boleh tolong. Kakak can help them, right?
Yeah.
Yeah.
I got a question, doctor.
Siapa ya?
Brian.
Okay, Brian.
Doctor, if let's say if I'm doing a project and then I do not have the data set, means I have to create my own data set. Okay. So the data set means I have to find my own image lah. So if the image is dirty, means tak bersih sangat lah. Means got some background, got some stuff that is not the information. Can I continue to use it?
There are many risks because this because you are also first time using the tools and using the machine learning punya model kan. My worry is that you are not just struggling about the model, but you are struggling with your data set. If you said your data set is very clean tadi, very clean, and there are many good quality, it's okay. Because I'm afraid you try to validate the model, you try to know, okay, the model working well or not. One challenge. The second challenge is how are you going to select, or how are you going to ensure the images that you have are good enough to represent the classes. If you can if you can ensure the quality is good, then it's okay. If not, you will be confused why your accuracy is low. Is it because of the model or is it because of the images? So the one that I provide here, Iris, because it's already validated, satu. I mean, many work have been done on Iris, and it's a numerical value. What I want you to achieve in this exercise is for you to familiarize yourself with the tools, how to pass it, how to make them as input, and then what will be the output, how you label them into 3 classes, and so on. So it's very clean data, validated data, and then it's confirmed you can achieve more than 80% accuracy. But Brian, if you think that you can get good quality images, then that's okay.
Okay.
Then proceed with the FYP one. Yeah.
Doctor, so
Yes.
for the iris data, we don't need to perform the pre-processing, is it?
No, because it's totally it is in Excel.
Okay. Thank you, doctor.
Doctor, we
yeah.
have to use images as data.
If it's Iris is in Excel. It's numbers. Let me find it here so that because it's already the features already extracted. It was originally from an image, from images of the flowers, but they already measure the let me see. They measure the petal and the sepal width and length, so they already convert it into numbers. I'm trying to get the Excel value. Okay, it's not here. Let me see. For example, you also can Google around. You just search for Iris dataset classification. You will get the data directly. It's actually numbers.
Okay, doctor. Thank you.
All right. Oh, okay. Let me share this one with you. Iris is not the image dataset. It is a number set. So you can see, this. So we have 4 features. Okay, sometimes they call it attributes, but actually it's 4 features. So meaning that every single data, it will have 4 values in it. Okay, so what we have is actually 4 values of sepal length in cm, sepal width in cm, petal length in cm, and petal width in cm. So all is actually in numbers. And it's already labeled with the 3 classes, meaning that if you have one feature, you already have the ground truth, which class this information belong to. Is it setosa, versicolor, or virginica? So it's label 1, 2, 3, or 0, 1, 2. Okay. Oh, there's no Excel here. Let me, where is it? Okay, data's folder. Oh, data index. Wait, this is the index of it. It should have the CSV file, but it's not here. Let me open it with a notepad. This is just okay. not here, but there are certain that website because this one is using its own format. But if you check on the one with the CSV, it will show you uh, um, the whole value of it. Let me see. I think this one, the one that show. But don't worry, this is the one that has many tutorials step by step, and even they have plot the original or the raw value to show that they are free. When you have this information, you cannot. There are two groups that you can classify, but there are two that is overlap. So it's a very good examples of why you need to use multi-layer perceptron rather than single perceptron. Do you remember that single perceptron? If we can draw a single line, right? So we can use single perceptron. But if there are overlap, and the shape is not a straight line, so we need multi-layer perceptron in order for us to classify it. Okay. Later, if I found the CSV file, I will share with you. Okay, hands down. So don't worry. You can pick Amer as the mentor. You can pick Kaka as your mentor. I think who else? Lukman also already explore the deep learning tools. Okay. Any other question? Aisyah ke? Anything nak tanya? Susi nak tanya? Okay. Alright. Okay, can we go quick on the next topic? Lepas so that we can stop earlier. Okay. It's a brief one. So today is the closing of our machine learning concept. We have spent 3 weeks discussing on machine learning. So I think there are many terms or information that we have shared through these classes. At least more or less you already know the architecture of machine learning or neural network. At least that's the most basic one. And then you know the process, you know there is training, you know there is testing, you know that training accuracy can be higher than testing accuracy. If your testing accuracy is higher than training, meaning that probably you have choose the data set not fair enough, or probably more easier version of your data is included in your test data. So therefore we will repeat the testing and training many times, or we can use k-fold in order for us to have an average value to validate the model, and also the training and testing that we did are good enough or not. Yeah, that's the purpose of k-fold. Okay, so before I forget, the attendance in the chat room, attendance. Okay, please go to the chat area and click for the attendance. All right. All right. So we go for next topic. Okay, this is a little bit heavy, but I try to simplify it. Right. So next one is actually evolutionary computation. Okay, so evolutionary computation, there are many mechanism or many data fall under the evolutionary computation. So genetic algorithm is one of them. Maybe you have heard of ant colony optimization. You may heard of bees optimization. You may heard of what else? Ant colony. There's another one. CA, cellular automata. So When you look at the names is actually very very near to biological concept. That's why the whole concept of those terms or those approaches, we call it evolutionary computation because it is based on the natural life cycle or natural process. It may happen among among animals, it may happen among human. Okay. So genetic algorithm is one of the subset of the biology. Okay, I'm not sure if everyone have knowledge of biology or not, because I know when you opt for engineering, the only compulsory subject is physics. So genetic algorithm is basically based on genetic concept. Okay, so whereby um, it is inspired by nature. Okay, the concept is it is not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change. Okay, so meaning that we uh, when we are talking about genetic algorithm, we're normally looking at the generation, how every generation from one generation to another generation we progress or we evolve. Okay, so this is similar to when you look at your family history. Okay, maybe many your grandfather, your great grandfather, maybe they have they are working as this, or maybe they have the physical characteristics. Maybe they are tall, they are fair skin. Okay, they have blue eyes probably. So when you look at the process until your generation, you can observe that what you inherit from your father, from your great grandfather and your great grandfather, you can see that what are the characteristics that are still there. So basically, we believe that the more generation we go, okay, when we you are born in the later generation, normally you are the fetus. Okay, the fetus can be in terms of your body, in terms of your brain or your mind. Okay, so it can be interpreted in different ways. Okay, but we know from one generation to one another generation you inherit something, but you are getting better and better. So don't be afraid if GA is using many biological term. So so as you know that genetic involved with the human population, meaning that um, yeah, probably we most of us born in Malaysia. Probably our father originally from Malaysia, maybe grandfather is also from Malaysia, but maybe great grandfather coming from other places. So meaning that they already evolved in different environment, and that's why you have different traits. So genetic involved with the human population. We are involved with the selection of pair because we know that when you want to go from one generation to another generation, you cannot have a single human to get to be in to produce a next of offspring or to produce child. You need a pair. So selection of pair is also one of the theory, uh, uh, a, a factor that um, a factor that will impact the results of next generation performance. And then we have humans pair, offspring, and one generation after one generation. So normally we start with the initial generation. Okay, if in machine learning we call it epoch. So many epochs. So epoch 0, 1 until epoch 10, 50, 200, blah blah blah. But in GA we call it S generation. Generation 1, generation 2, generation 3, because it's very similar to our biological concept. Um, so so every generation we have a solution or candidate. Okay, so generation 1 we have one population. Maybe that one population consists of 20 individual or 20 candidates. So these 20 candidates, they have their own solution or they have their own strength. So when they pair together, they try to retain the strength so that when you have the offspring, your offspring will be better than the parents. Okay, so that is basically the concept of it. That's why it's very related to Darwin theory. So in natural evolution, we know the genotype, phenotype, chromosome, gene, allele, and fitness. But in genetic algorithm, we use a more engineering terms to it, whereby coded string is how actually you nearly similar to DNA. We have a very many information in the DNA stream. So in GA, we also have the coded string that contain all the information or features that we want to include. Okay, uncoded point, a chromosome is a string, meaning that one person like me, if you would like to describe me into features or into information, I may have age, I have name, I have skin color, I have height, I have weight. So all that information, we'll combine it into one string. So one string represent one chromosome, which is me. So I'm one of the chromosome in the population. So we have gene string position. So if you can recall me, you have the age. Okay, age is one information. Name is one information. So the separator between age and name. So we have a separator here. We call it a string position. So we don't just have a very long information without the separator. Okay. And allele is value at certain position. So if you want to encode me into string of 0 and 1, okay, let's see numbers of age represented by 4 1 and zeros, 4 bits, and then maybe name encoded by 20 bits. So all that when you encode in 0 and 1, so I need to know where is the position of my name, where is the position of my age. Okay, and the fitness is the objective function value. So as I mentioned here, every candidate, it has solution. Every chromosome, it has solution. Meaning that if you would like to score me, okay, in objective function value, maybe you are considering the age, you are considering the name. Let's say we are trying to have to rate me in terms of risk for COVID-19. Yeah. So I'm living in a red zone area. I'm above 40, so I have higher risk to have a critical symptom or critical effect if I am infected by the COVID-19. So if you would like to label me in terms of risk, okay, so I may have high risk, but not 100% risk. Maybe I'm 75% risk because I'm I'm above 40, but in the red zone, but I'm healthy. I don't have any health problems. So you rank me at 75%. For you, since you are young and maybe you are in a green zone and you are healthy, so your objective function or your risk may be 10% only. So it's very low. So we normally rate every chromosome according to the score. So the score, that objective function value that I use now, is the risk of getting COVID-19 and will have a critical effect. Okay. Any questions so far? That's GA basically. So normally I will give a very basic example so that you can look at yourself. So in the whole we are a population. I am a chromosome. Okay. What is the gene or the genotype, the information that I would like to put to represent myself, F1 chromosome. And then what is my objective function value? So it depends on the application or depends on the problem that you want to solve. So if you would like to represent us in a COVID-19 scenario, then I put the fitness according to the risk. Okay, percentage of risk. So the higher the risk, the higher the person will be infected. So the lower the risk is it has lower risk to be infected. Okay. Tadi Hadi, you want to ask something, Hadi? I saw that you unmute the mic.
No, that was a sentence saya tengah tulis tadi.
Oh, okay. Right. So GA is actually an optimization method. Anyone understand what is optimization means? What is optimum?
It means the best.
Means the best. Okay, it means the best. So if you have many factors, you have to consider all the factors. So this optimum meaning that it is the best one for all the factors. It doesn't mean the best value for all factors, but maybe let's say factor A, it has the highest, but factor B, it may have the lowest. So optimum means it's trying to find the middle point that can fulfill or that can consider these factors well. Okay. So that's why when we call optimum, we don't call it the maximum or the minimum or the highest or the latest, the biggest, whatsoever. So optimum, it depends on what you derive on the problem. Okay. So let's say we look at the examples of optimization in communication. Yeah. So if you look at it, we would like to design what do you call this? A cell? No, wait, base station. Okay, base station that can get the best coverage or the optimum coverage. Okay, so as you can see here, 3G, 4G, and 4G LTE, you need 3 base stations in order for you to get the best signal. However, for 5G, you need only 2 base stations in order for you to get the best signal or the best coverage to it. So meaning that 5G is the optimized version. Why? Because you still get the best signal, but you only using 2 base stations rather than 3 base stations. So you can see that it's trying to balance out. So the best one is you try to reduce all the cost or the numbers of base station, but still the performance of the signal or the coverage is still very good. So that is optimization. Yeah. So optimization is, there are many problems that require optimization, similar to machine learning. Do you remember last time when you asked Madam Umi what is actually the best way for you to decide which machine learning model that can be the best? So one way of it is for you to use optimization method that can find the best machine learning model for your problem. Okay, how to relate that is you have a machine learning model. You know that there are many activation functions. There are many layers that you can try. There are a number of neurons that you can try. Okay, so your goal is for you to get 100% accuracy if possible. So in order for you to search or find the ways for you to get into that model, you have to try and error many times, right? Okay, let's say change this activation function. Okay, try change layers, try change rather than 4 neuron, hidden neuron, you change it into 3. So there are many ways, okay? Many ways, and you have to repeat that many times. So optimization come into the story when you ask it to search. Sometimes people call optimization as searching method. So what you want to achieve is to find best machine learning model for you that can get 100% accuracy. So optimization method will search all the parameters, search all the models, search all the activation function until your accuracy will be 100%. So accuracy equals to 100% is the fitness function, yeah, objective function value. So your goal is to get 100% accuracy for your machine learning. Okay, so so if you find papers hybrid ANN and genetic algorithm, meaning that they use genetic algorithm to optimize the NNN in order for them to find the best model that can get the highest accuracy. Okay. Okay. What is GA? GA is a random search algorithm. Okay, that's why I said sometimes people call it optimization algorithm. Sometimes we call it search algorithm. Yeah. So it tries to imitate the mechanics of natural selection and natural genetics. So as we know that we are going through a genetic process when we were born or for our next generation. So GA operate on string structures like DNA, biological structures, to evolve in time according to the rule, the survival of the fittest. So we believe that the more fit a person, it will be maintained in the population until the next generation, because we want to keep the best traits of this person. It is random, okay, but structured information exchange. I will show you what is the basic process of GA. So in every generation, a new set of spring is created using parts of the fittest member of the host set. So it sounds like a little bit cruel, okay? It sounds like that, but that is how we try to strive for a better population or a better members of the population. We know the more fittest you will be selected, and you can produce better children or better population later on. Let me show the okay. Okay, so this is the basic process of GA. Okay, what you have now is okay. So okay, that's okay, Siva. All right. What you have now is, firstly, you must have population, meaning that a population size of 20 chromosomes, meaning that there are 20 people in that population. If you have 50 chromosomes, meaning that there are 50 people in the population. So that's population. So every population we know that we have encode value, okay, encode information stored by every individuals, okay, and we know that everyone has their own score, or we call it fitness function. So when we have this population, we evaluate their fitness score, okay, or fitness function. We rank them normally. So the highest score up to the lowest score. So if we are looking at the COVID risk percentage, okay, we will sort the person with the highest risk up to the lowest risk. So meaning that the older you are and more health problem you have, meaning that you will be at the high rank of the population, and those that are younger, you are fitter, you don't have any problem, and you are in the green area, green zone, meaning that your risk score is 0. Okay, once you have that ranking, we would like to select. So what is our goal now? Our goal now is we would like to reduce the risk of COVID-19 infection. So we need to select. Which one will you select? The one with the high risk, with the risk score, or with the one with the lower score? Which one do you choose as a fittest? Anyone? Ame?
Amir tengah lari.
Ame lari. Ame ni. Hazman, which one is the fittest? Soalan saya, we have population kan? Let's say we have 20 people in the population. We rank everyone. Fitness function is the risk of COVID-19 infection. So those are older, okay, other medical problem. And in the green zone, in the red zone, they are having high score or high risk. Okay, those younger, no health problem, and green area, they will have lower risk. So we rank them. Now, when we want to select, our aim is to eliminate or we want to reduce the COVID-19 infection. Who will be the fittest chromosome? Who will be the fittest individual? The one at the high rank or the lower rank?
Lower.
Okay, so the fittest are the lower. We would like to select them more so that we can get a fitter person later. Okay, so you have to terbalikkan lah. You have to invert the list. So now we are looking, walaupun the score is 0, but with the fitter person is actually the one that nearly to score 0 because they are the fittest one. So once if you want to select, you will select them. So the fitter they are, so the higher probability that you will choose them to be pair. So katalah, let's say we have 20 people just now. So when we want to pair them together, we will pair them randomly. So of course, because it's random, so that's why you may pair a lower score person with maybe a medium score person or maybe higher score person. So maybe let's say score risk COVID is 90%, you pair with someone with 25% risk. So 25 and 90. So this 2%, you select them randomly and you choose them. Now you pair them together. So this is what we call as pairing. Okay, we select them because we want to pair, because we know that in order for us to produce next generation, all individual must be pair and they must have children or offspring. Then only we will get a better generation. So selection. Then we have the crossover, mutation. Okay, crossover and mutation. I will explain with more example later. So then the offspring will be the next population in the next generation. So basically our target is we will get better people, more people in the next population that has nearly 0 COVID-19 risk. That's going to be the ideal case. Okay. Let me see. Okay. So when I mentioned about the crossover, okay, let me see if I have better. No. Okay. Normally when we have this is our population, we rank them together. Okay. Then we pick 2 randomly. Okay. Let's say the winner is the one that has low risk, the loser is the one that has higher risk of COVID. We recombine or we cross over. Okay, recombine or crossover are similar. So what we do is we swap the information. Okay, so that the winner will have a cyan color here and the loser will have a green value here. So they will swap. So this is the crossover. The crossover, let's say they are mutated. Okay, rather than you have this cyan, green and cyan color, but suddenly you are mutated. So the red area is the value that you change randomly. It's not based on the partner, but it is based on the random function. So therefore, you will have 2 new individuals whereby maybe this one, it only has supposedly it has green and a bit of cyan here, but this person will have cyan, red, cyan, green, and cyan color. Then these two are totally different from their parents. These are their parents. Their parents originally are green and cyan, but the offspring or the children will have, they may have all green, but if we are looking at here, it should be swap. So we have a cyan color here, and another children has more colors to it. So it's when we compare this, it's totally different. So this is generation 1, okay, because they are the parents. This is generation 2 because they are the children. So these children will replace the population. They will replace their parents. Okay. So supposedly after many times of cycle here, okay, many times of life cycle or many times of generation, at the end, we will get the best optimum person or the optimum individual that created from the GA process. Let me see. Okay, let's see this video. Did I share? Okay, let me stop sharing first because I think last time I didn't share with the son. Okay, it is. Okay, so this is the video. Okay, how do you understand the video? Is so that at first it was randomly and then it will be targeted and maybe later you will find the best result for it. Okay, let's watch this. So the food is the mouse, yeah? So the line is the snake. So snake is trying to find the food. So the 20 times here represent the generation. So this line meaning that we already find the way to find food. Okay, let's see, we have obstacles represented by the black cube. So as we know that we have obstacles, so the snakes cannot find a way to reach the food, but then the mutation occurs, okay, meaning that we try to find other ways. So when we have mutation, we will find the way that can get rid of the obstacle or alternative route, and then later on we will find one solution, one path that can achieve to the food, the target. Okay, so that is one examples. If we would like to let's see, try to imagine what is GA. I want to show you one more video. Let me exit from it first. Okay, right. So this one, the next video, is a very good one that can show you the evolution. Okay, the evolution of the solution, whereby your challenge here is trying to climb the hills or the path you would like to reach to your final target, but there are many hills, valleys, and everything, and the rough surfaces. So you need to evolve, or you need to change the design of this cart in order for it to pass through the obstacles, and finally it will reach the destination. So there you will see many designs occurred, meaning that it is mutated or it can be crossed over in order for us to find the best solution. Okay. So it's a 2D car, meaning that we may have 2 wheels, we may have some boxes to balance. So as you can see that at the initial point, the solutions are stuck, okay? Meaning that they are not fit enough yet. They only can travel very short distance, or later they will get stuck. So we try to change the design. So every design represents 1 chromosome. So when they have to start from the initial point. So once they are stuck, meaning that the design is failed. So we got score for every single design. So we are looking at the fitness value here, max fitness. So the higher the fitness, so the better the design, and it can travel more distance. So genome represent the design, okay, or the individuals. Generation is the one that will be, let's say we have a population of 20, meaning that there are 20 genome, right? So as you can see, this one is quite good. It can travel quite far. It's able to climb the hill and pass through the valley, but this one is stuck. So you realize that there are different wheel size, different wheel position, different box position, different size of plank. So it's a long process, because we know that in order for you to find the fittest, it has to go through many generations, and you have to find the fittest among the population, retain the features, then only you will get the best solution. So after generation 20, we have a kind of good chromosome, a good individual here, good design that can overcome the valleys, go up the hills. So the score is the distance. The fitness function is the distance. So as long as still moving, so the distance will be measured. So as you can see, even though it's stuck a little bit, but the design of wheels and the plank are still able to get through. So after generation 37, this is the first car that beat the track. if we have a different score or different fitness function, probably we can get include the smoothness of the movement, not only distance. But this one is only distance, so that's why it doesn't matter if you start or you have to roll many times in order for you to get through the obstacle, as long as the distance are the most maximum one. Okay, so it is so if you can see the generation 99, it's improved the speed and it improved the smoothness, and it's also able to finish the track successfully. Okay. All right. Yeah. Okay. I hope that you are watching that video just now, but don't worry. It will be included in the slides, so for you to watch again later. All right. So that's video ends our class today. Any questions so far on genetic algorithms? Because that's going to be one of my favorite question in final exam.
So basically, genetic algorithm, we only take the good gene, right?
When you do select, it is randomly selecting. However, it is taking into account the ranking tadi. So if your ranking, there are many ways. Sometimes they just only considering the best one. I mean the top values, then only they will keep on pairing that top person with other low rank individual. But there are also methods that try to, try to be fair, because not necessarily if that person is, have high score or high risk, there must be some other characteristics that can be considered as strength. So in some way they try to not really random, but they want to give a fair chances. So let's say you have 20 people in the population, you randomly choose, but all must be selected, meaning that you will not disregard the person that has a very low score or high risk of COVID or whatever. So still be selected. Who you will pair with, that's going to be random. Okay. So it depends on the algorithm itself, or how strict you want the selection to be. But normal one, like the one that you see on the last design of card, as you can see, they are still giving chances. That's why there are design that it's not working, but they just want to try it. That's why you can see the repetition of that design come again and again in the next generation, meaning that that person or that solution may seem weak, but they are still selected in the selection process. They are selected as the to be paired with other individual. Okay. Okay. Anything else? GA is very near to us. GA is something like you don't have to remember the process, because if you look at yourself, that crossover means what you inherit from your mom. You are inherit something from your mom or your father, meaning that the results of crossover. You are crossed over because, let's say, your mom has black hair, you have black hair. Your father has maybe a little bit brownish hair, and then your mom is fair skin, you have fair skin, but your mom maybe she is short, but your father is tall, but you got the tall. You are tall, so meaning that you are crossover. You have certain characteristics from your mother and certain characteristics from your father, meaning that you are experiencing crossover. Mutation means your father doesn't have it, your mother doesn't have it, but suddenly you have it. Okay, so normally we relate it to the this or what you call it, disabilities sometimes, or changes in your DNA genes. Okay, but don't look at that perspective only. Maybe you are mutated if, let's say, your parents have brown eyes, but suddenly you have a green eyes. So you are mutated. Okay. So if we are looking at X-Men, they are mutated. So Wolverine originally was a human, but then it has the blades from the hand. So yeah, they are mutated version, meaning that never been parents never have that characteristic, but suddenly they have. So it's very easy to remember, and you know that it goes through the cycle. You select, you pair them, then you cross over, then you mutate, you reassess again the score, and then you put them into population, repeat again the process until you find the most optimum results, or the most optimum fitness function. Okay. Any other question? No? Yes?
No.
Laju je Azman. No. I know it's very hot nowadays. So even to focus pun susah. My fan pun dah full speed dah. Okay. So if we don't have any question, I know that Hadi has class at 5. Others, maybe you are thinking about the machine learning assignment already, or maybe you are thinking about GA, a new topic that you have to digest. Well, so you can have another hour of the class for you to search around and try to decide. Maybe you can make do preparation for your next machine learning assignment. Yeah. Okay. Everybody fill in the attendance sheet, because last week there are few missed it.
Doctor.
Yes, Chai.
Doctor, you just now you say you want to brief about the project.
Thank you, Chai. Aduh.
Yeah.
Thank you, Chai. Let
No problem.
me open up the slide. Seriously lupa. Let me open up the slide first. Project. Okay. Sekejap the slides not open. Sekejap Let me check again. 10. Okay, sekejap I edit sikit je. Week 10. This is week 10 week 11. Week 12. Tapi we will discuss if the milestone is too much. Okay, sekejap I share. Okay. All right. Okay. So this is about the mini AI project. Okay. We are implementing it since starting this week until week 14. We got the pairs, and there are one team with 3 members. So that one, I think Brian already recruit Dealdine to their team. Yeah. Okay. Basically, these are the marks and milestones. M&M, chocolate M&M. Okay. So distribution of marks per project. So this is what I have in mind lah. But if let's say you don't want it too much, 30% is too much. Maybe you want to reduce, then it's up to the discussion. We can reduce the percentage if you want. Okay. So firstly is the proposal. Proposal is 10%. Will be due in week 11, which is next week. So here is basically proposal lah. the background, lit review, problem statement, objectives, methodology, data set, and references. So if you are working on the FYP project, meaning that it's kind of chapter 1 to 3. Okay, so this is week 11. In week 12, what we'll have is the interim report. So it can be experiment setup and preliminary results. So I will show you the example of it. It's not really detailed. It's not a it's actually a very brief report. I just want to know how well you progress with the project. Yeah. So in the week 14, you have to submit the final report of the project, where it consists of the previous one that you have in proposal, and with the results and discussion. Okay, so the only components that you added here from your proposal is only results and discussion. However, if your methodology change from the proposal, meaning that you have to update your methodology here. If your data set is changed from the proposal, then your data set has to be changed from proposal. So my advice, you have to ensure that whatever that you put in proposal will not have any changes, so that you can have less burden in week 14 to complete your final report. So this is the proposal. I think you have, I mean, you are very good in writing proposals so far, because you have done this in IDP and then you have done it in FYP. So basically what you have, you are familiar with background, lit review, the problem statement, objectives, method, dataset, and references. So please take note, all details are provided and according to IEEE style. Yeah? For the interim report, it's actually a very simple sheet whereby you just submit the objective, the task that you have, maybe the results. Okay, so in this example, this objective, task, input, and output. So it doesn't necessarily you have to complete the whole project, but I want to see that you are doing the stages according to your proposal. Okay, so if you look at the deadline, this is week 11 and this is week 12, meaning that maybe week 11 you just exploring on the data set and the tools. Maybe week 12 you are doing the exploration or configuration of tools in week 12. So not really, not necessarily you have the final output yet. Okay. So in the final report, what you have is more or less similar to the proposal plus the results and discussions. Okay. All right. Any comment or any percentage that you want to reduce or add? So is this clear? Marks and milestones, M&M. So next week we have the proposal. Week 12 we have the interim report, and week 14 we have the final report. So do remember that in week 12 we also have the due submission for ML exercise. Any objection? Are you okay? Because this is the work by pair or by 3 people in a group. So I hope that you can distribute the task evenly, so that I know that you will have more thing to do, especially for your final year project and other assignment from other subjects. So please let me know if you are having trouble or stuck somewhere. It will be smart if whatever, you will be lucky if you are involved doing the FYP, because FYP you can use in this project and you also can use in your machine learning exercise. But if you are not, you know, you are not really, you don't have that, but let's say your project is proposing on this data set, maybe machine learning, let's say, and that data set you are planning to use machine learning, so use the same data set for machine learning exercise so that you are only doing the same thing for project and also the machine learning exercise. Okay. The rest?
Okay.
Okay. Alright. Lemah je kan? Banyaknya kerja doktor.
Yeah.
That's why I'm asking. You want to a little bit apa nak. You want to extend sikit ke? Do you think I'm not sure when is the deadline for FYP, and I'm not sure what is it the same one? I mean, do you have to present by week 14 or you can present week later week before final exam? If possible, I don't want to clash with the FYP deadline and also other subjects deadline. So let's say if you have a few deadlines in week 14, let me know. So that I will not, you know, at least I give you 1 or 2 days after that deadline, I will give the deadline for AI.
Boleh confirmkan balik tak, Cik?
Okay. Please, because I know the other subjects maybe they didn't announce on the submission date lagi kan. But this is my plan lah. So let's say week 12 you have other tests, for example, you have tests dekat subject, other subjects. So maybe interim report not week 12, we can extend it week 13. But let me know, okay, before I, you know, I don't want to make you stress and I also don't want to make myself stress. So we try to find the best implementation lah. Or another one is you don't want the interim report, I can disregard the interim report so you can submit proposal and final report only. That is also possible.
Okay juga, Cik.
Hazman je ni yang bersuara ni. The rest tak bersuara ni, Hazman. Are they sleeping?
Saya okey je. Setuju dengan Azman.
Oh ingat. Setuju dengan saya ke setuju dengan Hazman?
Saya pun okey. Okey je.
Okay apa? Okay without interim report ke? Okay with interim report or all my plan
Without
Without
interim report code.
Without interim report code. Ada code pula kat ujung dia. Siapa yang tak bersuara sangat ni? Susih rasa? What do you think? Are you okay? Brian, no problem. Brian has extra. Without Brian has extra hand. Those yang partners je ni, pairs je ni. You have to work harder. I don't want to ask the Aldin. The Aldin is okay je.
Yes, doctor. I think I have to try first and look because it's hard for me to know how much time I will need. I will see during the next weeks, I think.
Oh, okay. So it seems like majority would like to disregard the interim report, because you don't want to have another deadline, right?
Yes, doctor.
Okay. Who would like to disregard? Let me stop sharing lah. Who would like to disregard the report in week 12, interim report? Aina Fakihah ada dua, clapping hand and raise hand. Also the rest are okay. They are not raising hand. We have 26 people here. 26 minus the master student. I think 3 master student. So 24. Kakak and Peggy not raising hand, Hadi. To say, okay, 17 raise hand. So meaning that we will disregard the interim report. So you only have 2 deadlines for the project. Next week is proposal and week 14 is the final report. But the final report deadline will depend on other deadlines that you may have, especially the final year project. Okay? All right. So you can lower your hand. Okay. So project done, machine learning done, GA done. Any other question? Anything else? No? Yes? Tak ada. Alright. Okay.
I got one question, a quick one.
Yes.
Our project all need to include data sets, right?
Yes.
Or not necessary.
I will strongly encourage you to use dataset. If you don't use dataset, meaning that you need to collect your own data, or you need to run or experiment it yourself. So I'm not sure. It depends on the project, your project. If you think the dataset is impossible to get, then you may use your own dataset or your own data collection. Or probably you are using something that has been trained, but you want to test on your own environment or your own setup. So no need dataset then. Is it clear, Brian?
Means it depends on situation, right?
It depends on your problem and your
Best
application.
we have.
Best you have it so that it can show the performance better. Because if you test it yourself, maybe you only do 10 trials, 5 trials, or maybe supposedly 10 people, but you only get 2 people. So it's not very conclusive.
Okay, doctor.
Okay, all right. If you have other question later, once you are writing your proposal, maybe you have more things to confirm. So you can just ask me via WhatsApp. Please put in group so that, let's say, everyone else may have different issue or different confusion. So at least I don't have to answer many times on the same thing.